Data quality is a first class engineering concern, not an afterthought you bolt on if there's time, and you validate at every stage, at ingestion, during transformation, and at serving. Check the four fields here. Structure. Are the fields present and correctly typed? Then content. Are the values reasonable, complete, and within the range you expect? Freshness. Is the data actually arriving on time? And finally, the business logic. Do the numbers reconcile with what you already know to be true? Here's a concrete horror story that ties it together. A payment pipeline suddenly shows zero transaction from an entire region. The job succeeded, a green check mark, because technically it processed the zero rows it received. But the data is completely wrong because an upstream connector failed silently and sent nothing. A freshness check and a row count check would have caught that instantly. That's the difference between validation and not validating the data. Here's a mental split that helps. Validation is like a gate, or let's say a stop, and monitoring is the smoke detector. Validation stands at the door and refuses a bad batch entry, that is, in the moment. Monitoring sits on the ceiling and watches the trend, so it can warn you that something's slowly heating up long before it catches fire. You need both of these. A gate that never watches the trend will miss slow decay, and a smoke detector with no gate lets the first bad batch straight through. Validation catches a single bad batch. Monitoring catches the slow decay. The problem that creep in over time and never trip a hard error. A pipeline can pass every schema check and still quietly degrade. Records start arriving late. The row count drifts downward every week. The null rate on a key field creeps up. None of those throw an exception. They are not crashes, they are erosion. Monitoring watches these signals over time and alerts a human before the bad data spreads downstream into reports, into models, into customer facing workflows. The goal, stated simply, is that you want to find out from your own dashboard that something is off, not from an angry stakeholder forwarding you a screenshot of a wrong number. One of those is a quiet Tuesday fix, the other is crisis. Let's look at what makes the pipeline trustworthy and then run it. I'll bring the code on screen again. First, the run quality checks inspect the clean batch. How many rows? How many were rejected? The null rate on response time. Whether every region is valid and whether the data is fresh. It returns a report with a simple passed flag, a yes or a no, on whether this batch is safe to serve or not. And then the observability module emits the exact signals a real monitoring tool would track: volume, freshness in minutes, null rate, which regions showed up, etc. Let me run the pipeline and show you the report and the metrics printing. Then watch this test I feed in a batch dated the year 2000 and the freshness check fails and marks the whole report as not passed. There, the stale batch is caught and flagged as failed before it could ever reach a dashboard. That is exactly the silent failure we opened the module with. Caught automatically. Pause here and change the check so it hard fails the pipeline when the null rate goes about 50%. Lineage deserves a special emphasis because it answers every question everyone panics about, and that is what else is affected when an upstream table breaks. Lineage instantly shows you the 12 dashboards, 3 modules, and 2 downstream jobs that depend on it, so you can warn those owners before they discover it themselves. Without lineage, that blast radius is invisible, and you find out about each affected system one angry message at a time. Let me name this discipline properly because it's more than monitoring. Monitoring tells you whether a job ran. Observability asks a deeper question. Can you understand what changed, why it changed, and why downstream trust might be affected? There are 5 pillars to it. First is freshness. There are 5 pillars to it. First is the freshness. Is the data arriving when it should? Second is the volume. Is the amount of data normal or did it suddenly half? Then schema. Has the structure changed unexpectedly under you? Lineage. Which downstream reports and models depend on these upstream data? So you know the blast radius when something breaks. And finally, anomalies. Have the patterns shifted in ways that don't look right? The reason this matters so much, failure in data isn't binary. A dashboard can load perfectly every light green while showing completely stale numbers. Observability is how you see that when a simple did it run check never would. Here's why lineage, in particular, earns its keeps. Let's go back to that opening scene. The executive dashboard is suddenly under reporting revenue. Without observability, you are guessing. You open 10 tabs, 10 dashboards, and start poking around, hoping something jumps out. With observability, freshness, and lineage views let you trace the metric backward, link by link, from the dashboard number to the analytics table that feeds it, to the ingestion task that failed overnight or the upstream schema that changed. What would have been a frantic, all hands, half day investigation becomes a 5 minute trace. Observability doesn't just find the problem faster, it's the thing that keeps people trusting your data at all. Because they know that when something does go wrong, you'll catch it and explain it before they even notice. And notice the theme running through every guardrail. Each one makes a failure visible and safe rather than silent and dangerous. Rejections are counted, loads are idempotent, bad batches are blocked at the quality gate. Decay is caught by observability. None of these make the pipeline fancier, they make it honest. A pipeline that tells you loudly when it's wrong is worth 10 that quietly hope they're right. Let me assemble everything into one picture of what reliable actually looks like. Source to serving with a guardrail at every stage. Extract the raw data, transform it, cleaning what you can and rejecting what you can't with clear reason. Load it through a repository with transactions and idempotency so reruns are safe. Then run quality checks before you serve so bad batches never reach anyone. And have observability metrics watching over the whole thing. So slow decay gets caught early. That, not a bigger database or a fancier tool, is what makes a pipeline trustworthy. And it's exactly what the Module 4 hands on project is. A small but complete version of this you can run, read, and extend. The everyday habits that carry all of this. Model the full path before you build. Source all the way to serving so you know where every failure point is. Choose storage by access pattern, not by reflex. Centralize persistence behind a repository and make your writes idempotent. Validate structure, content, freshness, and business logic at every stage. And treat observability, freshness, volume, schema, lineage, anomalies as part of the deliverables, not a nice to have that you'll later add on. Later, as we keep learning, never comes.